Okay, so once again, good morning everyone. So our topic for today is from platform-specific model to executable code. So that is two different topics, no? Focus on platform-specific models and the executable code. Now, uh, one platform-specific design has been produced, no? It can be used as the basis for an implementation in executable code. No, actually, specifically in Java, no, in Java programming, uh, the process is similar for other related languages such as C++ or C Sharp. No, now the production of Java implementation, no, starting from the PSM diagram. So our last presenter discussed the PIM, the PSM, no. So from the PSM diagrams in modular description, class definition in Java can be produced with some degree of automation. So each construct in the PSM class, no, diagram needs to be mapped to programming languages. Then now, an association directed from, if let's say for example we have class A to class B, that can be implemented as an attribute of A with the name of the B end rule. So to give us more details about the order association, unordered multiplicity association and corresponds, the unordered multiplicity association and correspond to the Java set and Java list, also covered with the mapping of UML elements to Java, let us all welcome our presenter. Go ahead, sir.
All right, so thank you, Dr. Marmelo. Hi, good morning, classmates. Once again, my name is Rodney, and I'm about to present chapter 6 from with the title from platform specific models to executable code. Specific design has been produced, it can be used as the basis for an implementation in executable code. So in this chapter, we will show the mapping from a Java PSM or the platform specific model to Java code. Okay, so once again, sorry for any inconveniences. So in this chapter, here are actually subtopics na i-discuss for under chapter 6. So let's proceed right now to 6.1, that is production of Java implementation. So in this subtopics, starting from the PSM diagram and module descriptions, class definitions in Java can be produced with some degree of automation. Yun nga yung sinabi kayo ni Sir, in this chapter, we're talking about the degree of automation from the stick models going to this executable code. And each construct in the PSM class diagram needs to be mapped to a programming language construct. Here is actually in table 6.1. This here the list of the focus on three, itong tatlong nandito sa pinakababa. Because from this table, it is seen that the most of the class diagram elements map directly to corresponding elements, merely with different keywords using used instead of read only, which is this one. However, the last three tests are more difficult. I've said earlier, an identity attribute has the constraint that no two objects of class can have the same value. This means that the constructor must check if the value has already been used, and abort the construction if it has. Likewise, operation that modifies the attribute. Here's the presentation for figure 6.1, which is the correspondence of association and the program data. An association directed from class A to B. This one implemented as an attribute from attribute of A with the name of the B and role of an appropriate type. If B has multiplicity of 0 to 1, the attribute simplify has type B. For other multiplicities, the attribute will be a collection type. Certain forms of such association and correspond very closely to Java data structures, such as you can see on the figure 6.1. Ito. First, an ordered association and of this one. Second one is an ordered asterisk dash multiplicity association and corresponds to a Java list. The third one, an ordered multiplicity association and corresponds to Java set. And lastly, a qualified association with one to one multiplicity unqualified corresponds to a Java or an array or multi-dimensional array if the qualification types are all rings. Here is actually the example of the program. Okay, so using these rules, we obtain the file outline class declarations for the Scrabble system. I believe the example already on uh, chapter 4 earlier. So in unified mode-rich expression map directly to Java expressions, most operators such as addition, multiplication, and subtraction on numbers are represented by the same symbols in Java. Walang bago dito sa tatlong operations. Unlike in division, it is represented by, I believe it's forward slash, mode by the symbol of percent. Operations such as backslash and forward slash or greater than or equal greater than semicolon direct equivalents in Java such as add all and contains all on collection. I believe this was also explained already by the previous reporters. So the translation frames to executable code is the most complex step and can only be partly automated. The decisions required are first, which class or classes are to be responsible for maintaining the truth of a particular constraint. If the constraint is a class invariant, then it would normally be the class which is responsible for it. However, constraint attached on association might be managed by either or both of the classes that connects. The second one is what data structures to use to represent associations and attributes. So, yung mga structures na pwede gamitin para mag-represent association and attributes. Lastly, algorithms to use to implement, create, and update maps. On the second part of this chapter 2 is synthesis of Java code. If we're thinking about synthesis, this is actually distinct entity formed by combining two or more different things. So in this subtopic, In the following, we describe an automated program synthesis approach, which uses the following code generation strategies. So the first one are, the first one is classes are responsible for maintaining their own local invariant, only that is invariant which do not involve features of other classes. All other invariants are made the responsibility of a single controller class. This is actually an example of the class representing the entire system. The second one, the basic types are mapped to Java, as in table 5.3. I believe nakita nyo siya kanina, yung sa topic ni Sir. Basta nakita nyo siya kanina, parang may table na nagko-connect siya. Makikita niya siya later part. And collection type in figure 6.1, which is yung kanina, yung may which is ako na may ito siya. Apart from algorithms already defined in the PSM, the algorithms in the generated code are simple brute force iterations over all objects of the circuit. They may be very inefficient in some cases. In this figure, the figure 6.2 shows the architecture translation which takes place from UML to Java, from unified modeling going to Java structure. Controller interface lists the externally available services of the generated executable. Typically, the generated code is the functional core of a system, and this interface enables it to be used by the GUI or graphical user interface for the. In this table also in the 6.2, it actually describes how particular kinds of feature in UML are translated into constraint A going to be attached to the association RS linked to attributes of connected classes, systematic translation, iterate through all up from X going to uh, X to the end, connected by RS, evaluating A, X sub 1 to X to the N for each. And if this is true, it will perform an action establish B, X sub 1 to the N power. So, for example, in the class diagram of figure 3.7, the constraint triggered is equal to true. Therefore, alarm is equal to true. Has the following translation to code. This is written in controller class which has sets. Ito yung magiging coding niya, which is all existing system and sensor objects. In this table in 6.3, which is low constraints and associations. So in 6.3, this is actually this shows the translation of some local expressions into Java. Var e in cases 2 and 3 denotes the variable ranging over e in context in which the expression occurs. For example, for system, var system and system X in the triggered implementation shown here. So later part may encounter natin yung thing yan. All right, here is also other example of our representation of uh, table 6.4, which is the update for local expression. So from this table, this is the corresponding representation in Java. So as an example, the post contains guesses dot value of add guess, and the lottery system is interpreted as the codes guesses that add, then open parentheses no integer, and then open parentheses x, close parentheses, then close, then semicolon. In Java, where guesses is a Java set, there is also a systematic translation in the state charge to code for operations specified algorithmically. So in class C, sorry, class C describing the application. So then created type for the base type to the is actually this the representation. So in the code of OP, where G, act, and act are the translations of G and act respectively. For subtopic 6.3, this is entitled Synthesis Case Study. This is actually the following topics will gonna be an example of a case study. So the first one is the railway signaling system. So the synthesis processes can be illustrated by a simple example of a reactive control system for managing the passes of trains through a railway network. So in figure 6.3, this is actually a class diagram of signaling system. Okay. So there are many constraints that can be defined for this system, but we'll only consider three. The first one is C, if any location is in a route that is occupied, then the route is occupied. This is actually the sample coding. This is the sample interpretation. So C3, if a route is not ready, some switch is in neither the normal or reverse position, then it is not traversable. So traversable is actually, it means that it's actually in a state of move, or you can actually or this is actually a distinct entity formed by combining two or more different traversable rather is actually traveling across or moving or pass along through a certain phase. If a route is occupied, its signal must be set up to stop. So this is actually the interpretation of that. Of this, among of this, C3 is a local invariant of route and the others are global, which is interclass. And here is actually the example of the coding. So the generated code is as follows. A class system types, which is this one, is used to hold all the definitions of enumerated types in the system. It also contains classes such to implement the OCL collection data types. This is other example of the coding. So it actually checks on the set local signal. and add low signal, which arise from the fact that this association and has multiplicity of 0 to 1. Here's another example of coding. So in this code, the local invariance of a class such as ready is equal to false. Therefore, traversable is equal to false, which is off. This is another example of the coding for the chapter, sorry, for rail signaling system. All right, so let's just gonna proceed right now on 6.4, which is study again. This is actually an inheritance example. So this example illustrates how inheritance and method, pre and post condition constraints are translated into Java. So I believe this was also discussed in chapter 5. So this is actually an example of an illustration of example. So in figure 6.4 shows the class diagram of this system. This is actually the pre and post conditions. We're in class A. Um, pre is true. The pre-condition is true. Then therefore the post condition result is equal to ATT times 2. In class B, wherein the precondition is true, therefore the post is result is equal to ATT times 4. And then in class C, which is this one, the precondition is ATT is it's actually great. Sorry, it's less than 100. Sorry for this typographical error. It's 100, and then therefore the post is result is equal to ATT plus 4. And lastly, on the class D, the precondition is ATT is greater than 3. Therefore, the post result is ATT result is equal to ATT times 9. This is actually another example of coding for the inheritance example. Actually, I just like to let you know if you can visit the YouTube channel of Dr. Marmelo. I've also posted there was also a video, or you can actually see a video there also of a representation of an inheritance class. So this translates directly into Java code. This is actually this the coding, and another one of operations are expressed by testing the negation of the precondition at the start, which is I believe so, which is pre means before, which is sorry, at the start of the operation of the code and existing from the operation with it. This test is true. So coming up next is the 6.1, which is another case study or synthesis case study. This is also a derived attributes example. So in this example, it illustrates the generation of code to maintain the values of derived attributes in order to satisfy their defining properties. All right, so in 6.5, this is actually the figure 6.5, which is derived attributes example, wherein there are actually two class here. The first one is person and the second one is job. So figure 6.5 shows the class diagram of this. Generated code for this system as follows. All right, so no worries because this will gonna be also posted in our uh, Google Classroom for your references. Here's actually the extension. This is actually too long coding. So the definition of set job, set salary. So this is actually the concatenated example of coding, which is defining the derived attributes of person. Because job is an ordered association, the method is we're gonna be for this one. So is used to obtain the list of salary values such as JB.salary for job in for JB in jobs, so that the duplicate salary values will be retained at and sum. In the case of set salary, which is job X and salary X, the change to the salary of job X may require recalculation of the earnings of each person object whose set jobs includes job X. For subtopic of 6.6, this is actually repository implementation choosing a database. So a large number of databases that exist, MS Access, MySQL, PostgreSQL, and Oracle. So for data capacity, for MS Access, it's actually medium, and high for MySQL, PostgreSQL, and Oracle, and so on and so forth. This is actually the comparison of databases. So the referral integrity refers to the ability of the database to enforce the integrity constraint that is that if a table row with the primary key value X is deleted, then any row in table that has X as a foreign key value to the first table must be also deleted. So table 6.5 summarizes the properties and differences of these. Referential integrity refers to the ability of the database to enforce the integrity constraint, as what I've said earlier. Then any row in any table that has X as a foreign key value to the table must also be deleted. Coming up next is the 6.7, which is the production of XML Data Repository. Suppose that XML has been chosen as the implementation medium for storing the history of moves in the Scrabble system instead of a relational database. So this has the advantage of independence of any commercial database system, but means that data on moves and scores will be stored as possibly very large, such as text files, structured in a way that responds to the PSM or the platform specific model class diagram information. The data to be stored that must or the data to be stored must be structured as a directed uh, with regard to navigation from one entity, which is the master, and to another, the subordinate. In the Scrabble game, this is possible with move being the top level entity, with subordinates player and letter move, and letter move having subordinate with class letter. An example of XML file representing the move C, A, and B representation starting on the center square could be, this is actually the summary. All right, so the structure of XML file is defined by the data type definition or the DT file, which lists all the tags that can occur in the XML file and specifies their attributes and how they can be structured in terms of subordinate tags. Here's also the TD, the or the data type definition for the previous. A move consists of a score followed by a player, then by a sequence of letter move elements. In turn, a letter move consists of X and Y, X, Y, and letter elements in that order. A player consists of name, score, and player flag elements, and a letter consists of one. Symbol and score elements contains just string data, while the player flag can have either the value human player or the value computer player, with human player being the default. So the mapping from PSM class diagram to an XML BTD is the data must be organized wherein the roots of the XML entity. The other one is an entity E has attributes ATT1, it's ATT sub 1 to ATTN, and roles, which is role sub 1, and so BTD specification such as this one. An attribute is normally represented vector data if it is a number or a string. This a Boolean or element of an enumerated represented as an empty element, as with the player flag above. A role is represented as a list or single item of the entity F. It is attached to, depending on its multiplicity. For an A asterisk role, we would have this one. So, for example, for 0 to 1 role, question mark is used, and A sub 1 asterisk role means one multiplicity. The effect of this mapping is, there's actually two for this one. The first one is for each entity instance, its attributes are listed as subordinate tags with the attribute name of that instance. And the second one is a link. A subordinate object is represented by including the subordinate object within the elements of it. So an alternative way to specify the element structure of an XML document is an XML schema. So you can actually visit this one also if you wanted to know more on a schema. Writing XML for a class is a simple matter of printing out the attribute enclosed their tags. For example, the methods which do this for the move histories are, this is actually an example of that one. For in move, this is actually the coding. For in player, in letter move, and in letter, this one. However, parsing XML files and recreating object data is much more complex. There are two general strategies in parsing XML. The first one is what we call the or simple API for XML. These parsers and when the parser encounters XML tags or other content. And the other one is the DOM, or what we call document object model. These parsers build a complete tree structure containing the XML document. Their use of memory may therefore be much greater uh, SAX parser, but they provide a more convenient programming interface if large parts of the XML data are required, or if the data is to be modified by the program. So since the Scrabble, in this Scrabble example, we need to obtain all the information. DOM parsing is more appropriate in this case if only selected in terms, sorry, if only selected items were needed, SAX processing could be used instead. So this is actually another example of the coding. So since this Scrabble example, we need DOM parsing is more appropriate in this case if only selected items were needed, as what it said. So in Java 1.5 contains SA parsing classes in this org.xrnl package, and DOM parsing classes in the org that W3C DOM package, wherein we're gonna use this method for DOM. The first one is the element root is equal to document element, which is this obtains the root node, the XML data tree. The second one is the node list children is equal to that get child nodes. This will gonna get the immediate descendants in the data tree. Para siyang inheritance then, in the data tree of element E, that navigation along the children list is typically via an iteration of the form, which is this is the form. The third one is E that get tag name. It's obviously it gets tag name, a string or string of element E. And last is the CE that get first child, wherein it get first child node of CE. If the tree represents a tag that contains only basic data, such as a score, this obtains the data associated with CE. So this is actually an example of coding for the Scrabble. Okay. It's actually too long. All right, so just to summarize, we have shown how it is possible to construct platform independent designs and transform this systematically into platforms. And finally, to executable code. The methodology proposed here is similar in intention to that agile MDA executable UML, although we recommend starting from a more abstract CIM/PIM consisting of a data and invariants in place of the explicit message passing of agile MDA models. So here's actually my resources also. I've it's actually taken from our from the ebook from Advanced System Design with UML and MDA by Gavin Land, and also the site can also check for an example XML schema. All right, so I think that's it for today. So thank you for listening, classmates. That's all. Chapter 6. Thank you. Hello?
Hello, Sir Ron. Hello. According to ano po, Sir Marmedo, let's wait for him na lang daw po for a while.
Thank you.
Sir Mark, andiyan ka pa?
Andito pa, sir. Si Rodney. Si Rodney. Si Rodney.
Baka umalis lang saglit.
Oo.
Saan ka na ngayon,
Last
pre?
week na kayo nakapag-download ng book. May...
Yes, sir.
Yes, sir. Rodney, saan kayo nakapag-download? Sa Kikip, ano? Lahat may bayad eh.
Nung alin, pre?
Yes, later.
Dami.
I'm actually foreigner.
Wala.
Later po, sir. Send ko pa.
Sige, sir. Dito na lang, sir, sa ano natin, sa chat room or something. Para at least ko din. Thank you po, sir.
Mark,
Pre.